morning to all. In the previous lecture, we've seen that what is the algebraic element and transcendental element. Okay, what is the algebraic element? What is the definition of algebraic element? This one. Let K be an extension of the field F, and element A belongs to K is said to be algebraic. Okay, algebraic nahi hai, algebraic. This one is correct. Okay, algebraic. Over F, if there exists a non-zero polynomial P of x belongs to capital F of x for which P of A is 0. That means there exists a polynomial such that element A belongs to K is the root of that polynomial. Okay, then we can say that the element is algebraic element. Okay, the polynomial, such a polynomial does not exist. Okay, if then we can say that element is not algebraic, that is transcendental element. Okay, so here the root 5 is an algebraic element over Q. Okay, any complex number is algebraic over R. So by default we check the complex number. Okay, this one, any complex number A plus IB is algebraic over R. कोणताही complex number हा A plus IB या फॉर्म मध्ये असतो आणि तो कसा असतो algebraic over R. So we have to check that the complex number is algebraic over Q. Okay, this one. A complex number is said to be algebraic if it is algebraic over the field of rational number. Okay, जर दिला असेल Q, जर दिलेलं नसेल काही तर Q वर चेक करायचं आपण. ओके, जर दिलेलं असेल तर R वर दिलेलं असेल तर तो ऑब्वियसली काय असेल algebraic element. Okay, so I is algebraic over Q here, but this element, this is the complex element, x is equal to square root of 2 raised to 1 by 3 minus I is not algebraic over Q. Okay, and this is the definition of transcendental element. If K be an extension of the field F, an element A belongs to K is said to be transcendental over F if it is not algebraic over F. Okay, so there does not exist any polynomial belongs to that field F of x such that element A is not a root of that polynomial. Okay, here R is not algebraic over 2, but pi is algebraic over R. Okay, E is not algebraic over Q. Okay, any doubt in the previous lecture? Okay, so today we will see what is the minimal polynomial of an algebraic element. Next definition is minimal polynomial. Minimal polynomial of an algebraic element. Okay, look at the definition. Let K be an extension. K be an extension of the field F over the field F. K be an extension over field F. Okay, capital F. And A with any element belongs to K. Okay, is algebraic over F. Okay, so A belongs to K is algebraic over F. It means that there exists a polynomial belongs to F of x. Okay, ring of polynomial such that this A is root of that polynomial. Okay, so here A belongs to K is algebraic over F. And suppose the P of x is polynomial, is a polynomial over F of lowest degree, lowest positive degree. Okay, lowest positive degree. satisfied by A. Okay, then we can say that the P of X is called minimal polynomial. Okay, minimal polynomial for A over the field F. Okay, look at here. Square root 2. Okay, if A is equal to square root 2, let us assume K is equal to R and F is equal to set of rational numbers. Okay, we taken A belongs to here, what? K, which is equal to R, for example. Okay. Now tell me the minimal polynomial P of X, which is satisfied by A. So calculate first. X is equal to, let us assume X is equal to root 2. This implies X squared minus 2 is equal to 0. Hence, P of X is equal to X squared minus 2. Okay, here, so P of X, this polynomial is belongs to Q of X. Why? Because all the coefficients of P of X are belongs to Q. Okay, so hence this P of X polynomial it belongs to Q of X. Okay, so hence the lowest positive degree polynomial x squared minus 2. Okay, P of X is equal to x squared minus 2 is minimal polynomial. Okay, so there does not exist any polynomial less than this one. P of X पेक्षा कोणतीही कमी डिग्री असलेली पॉलिनॉमियल तुम्हाला इथे सापडणार नाही. Okay, this one is the also algebraic. Half the P dash of X given. Okay, no, P dash P1 of X, X square minus 2 into X plus 1. This polynomial also satisfied by A. Here the P1 of A is equal to 0. But this is the not the minimal polynomial. Why? Because the degree of that P1 of X is equal to what? 3. Okay, but P of X is equal to X square minus 2. The degree of this polynomial is 2. Okay, so we have to find the lowest positive degree polynomial such that element A satisfied by P of X. Okay, so this is the definition of minimal polynomial. Any doubt? Okay, असे
No, sir.
infinite number of polynomials येतील, but minimal polynomial काय असेल तुमचा unique असेल. Okay, infinite number of polynomials exist which satisfy by element A, but here we have to find only only one polynomial. That's why the concept minimal polynomial we are taken. Okay, is element degree of an algebraic limit. Okay, look at this one. What is the degree of algebraic limit? Let a statement प्रत्येक ठिकाणी common आहे बरं का. Let A be the next one of F. Okay, let K be an extension of the field over the field F or of F. Okay, a element A belongs to K. Okay, is is said to be algebraic algebraic of degree n over f. Okay, या एलिमेंटची डिग्री n कधी असेल over f if the minimal polynomial for a over f, okay, is of degree n. Okay. If k be an extension of field f, an element a belongs to k, it's said to be algebraic of degree n. या एलिमेंटची डिग्री n कधी असेल, जर त्या पॉलिनॉमियलची डिग्री किती असायला हवी, n असेल. ओके, जर एखाद्या अल्जेब्रिक एलिमेंटची डिग्री काढा असं म्हणत असेल तर काय करणार आपण, त्याचं मिनिमल पॉलिनॉमियल करणार, and whatever be the degree of that minimal polynomial, then it is a degree of an algebraic element. Okay, for example, again, k is equal to r, okay, and root 2 belongs to r, okay, and f is equal to a flash number. What is the degree of this algebraic element is, what is p of x polynomial? X square minus 2. So degree of what? P of x is equal to 2. Hence, the degree of algebraic element A, that is root 2, is equal to 2. Okay, any doubt? Okay,
No, sir.
this is the example number 1. Now tell me, what is the degree of this one? Second, if x is equal to or a is equal to, calculate karo. If x is equal to 5 raised to 1 by 4, okay, 5 raised to 1 by 4. Find out the degree of this algebraic element. Find out. Four. Is it correct? करेक्ट आहे का फोर नक्की? Yes, correct. X is the degree of that element A is equal to 5 raised to 1 by 4 is 4. Okay, get it. Find out the degree of this element algebraic element. A is equal to square root of 1 plus square root of 3. Find out. करताय ना? Hello. Find out.
Yes, sir.
Yes, sir.
काय अवघड आहे यार. let x is equal to square root of 1 plus square root of 3. Okay, this implies x square is equal to 1 plus root 3. Okay, this implies x square minus 1 is equal to square root of root 3. This implies x square minus 1 bracket square is equal to 3. Okay, over कशावर काढायचं आपल्याला set of rational number bracket हे महत्वाचं आहे over q. Okay, so this implies x raised to 4, okay, minus 2x square plus 1, okay, yeah, minus 3 is equal to 0. So this implies x raised to 4 minus 2x square minus 2 is equal to 0. This belongs to, okay, this is p of x. It belongs to q of x. And the degree of algebraic element, the degree of a is equal to square root of 1 plus root 3. Okay, square root of 3. Root of 1 plus root 3 is equal to what? Okay. Now, the next definition is monic polynomial. Okay, माहिती असेल तुम्हाला monic polynomial. What is the definition of monic polynomial? A polynomial f of x, okay, suppose belongs to capital F of x, ring of polynomial, okay, is said to be monic if its leading coefficient is 1. Okay, x square plus 1 is equal to 0, or this is the p of x, suppose this one is monic polynomial. Why? Because the leading coefficient म्हणजे काय, जो सगळ्यात जास्त पॉवर आहे डिग्री, त्याचा कोएफिशिएंट किती पाहिजे 1. ओके, 2x स्क्वेअर प्लस 4 हा तुमचा मॉनिक पॉलिनॉमियल आहे का? ओके, 5 घ्यायचे. No, because the leading coefficient is not 1. Okay. What is the definition of primitive polynomial? In the previous semester we have seen that. What is the definition of primitive polynomial? What is the primitive polynomial? आहे का विसरतात सगळे?
GCD of all the coefficients will be equal to 1.
Very good. The GCD of all the coefficient is 1. Look at here. If the polynomial is monic polynomial, then the GCD किती असेल all the coefficient? Monic polynomial implies primitive polynomial. Is monic, it implies it is primitive polynomial. Okay, but converse need not true. Okay, ह्या सगळ्या कोएफिशिएंटचा जीसीडी किती होते 1 and 1. किती आहे जीसीडी 1, इथे किती आहे 1, इथे किती आहे 1. Okay, but primitive polynomial does not implies monic polynomial. Give me example such that the polynomial is primitive but not monic.
5x square plus 2x plus 3.
5x square plus 2x plus 3. all the prime numbers घ्या इकडे. ऑटोमॅटिक जीसीडी किती येईल याचा 1. हा काय तुमचा प्रिमिटिव्ह पॉलिनॉमियल बट नॉट मोनिक पॉलिनॉमियल. ओके, एनी डाउट?
No, sir.
Now the next point is algebraic extension. Finite extension झाला, simple field extension झाला. Next point is what is the algebraic extension? Okay, look at this definition. An extension K of field F. An extension capital K of field F is called an algebraic. Okay, algebraic extension of capital F if every element is algebraic. Okay, over F. Okay, एखाद्या एक्सटेन्शनला K या extension over the field F. It's called algebraic extension of F if every element of K, every element of K is algebraic over F. Okay, तुमचा हा जर F असेल field आणि जर हा K असेल, या K ला algebraic extension of F कधी म्हणतात? जेव्हा प्रत्येक पॉइंट तुमच्या K चा is algebraic element over F. Okay, any doubt? Example, Q is equal to, this example here, root 2. Okay, and F is equal to Q. Okay, now root 2 is algebraic over Q, and every element of Q itself a algebraic element of Q. Okay, so here the Q root 2 is an algebraic extension of Q. Why? Because every element of this Q root 2 is algebraic over Q. Hence, this K is an algebraic extension of this Q root 2. Okay. Now look at the note. Okay, note. If capital F is any field, okay, कोणताही एक field आहे capital F, then capital F is an algebraic extension of F. Okay, itself a field is an algebraic extension of F. Okay, प्रत्येक field has स्वतःचा extension असतो, algebraic extension. Why? Because every element of F is algebraic element of F. Okay, since, look at here, why? Because since if any element, okay, arbitrary element belongs to F, we can define a polynomial belongs to the ring of polynomial f of x such that this a is root of that polynomial. Okay, if suppose here a belongs to F, then the a satisfies a non-zero polynomial x minus a is equal to 0. म्हणजे हा a काय करतोय, हा पॉलिनॉमियल, ओके, p of x असेल, जर असा असेल तर हा a p of x सॅटिस्फाय करतो. ओके, this x minus a belongs to what? F of x. Why? Because हा a तर तुमचा आधीपासूनच f मध्ये. Okay, आणि हा काय तुमचा coefficient 1, leading coefficient 1. And we have, if f is the field, we have identity element with respect to multiplication always in f. Okay, so this p of x belongs to capital F of x. Hence, that is a belongs to f is algebraic element of capital F. This implies F, capital F is an algebraic extension of F itself. Okay, any doubt? This is the note number, note A. Okay, so here, जर या A मधला कोणताही एलिमेंट F वर जर अल्जेब्रिक असेल तर त्या एक्सटेन्शनला काय म्हणायचं? अल्जेब्रिक एक्सटेन्शन. Okay, now here look at F is in itself algebraic extension of F. Okay, now the next example is set of all complex numbers. Set of all complex numbers. Okay, the field C. The field C. Okay, there is set of complex number. Is algebraic extension of set of field of extension of field R, set of real number. Okay, but the field C of complex number is algebraic extension of field R, but it is not an algebraic extension of field Q. Okay, C चा प्रत्येक एलिमेंट हा Q वर algebraic नसतो, algebraic element नसतो, but every element of complex number is algebraic over the field R. Okay, example number 1. Example number 2, Q root 2. Okay, what is the nature of this one? A plus B root 2, such that A and B belongs to Q. Okay, so any element of this field is in the form of A plus B root 2. Okay, where A and B belongs to Q. Yeah, form of the answer. Okay, so this implies x minus A is equal to B root 2. So this implies x minus A bracket square is equal to B square into 2. So this implies x square minus 2ax plus A minus 2b square is equal to 0. Okay, so this implies x square minus 2ax, okay, minus plus A minus 2b square is equal to 0. Okay, so here P of x is equal to x square minus 2ax plus A minus 2b square. This polynomial is belongs to Q of x. Okay, why? Because A and B are belongs to Q. It implies minus 2A also belongs to Q. A minus 2B square is also belongs to Q. So all the coefficients of P of x are belongs to Q of x. Hence, we can say that Q of root 2 is algebraic extension of Q. Okay, काय प्रूव्ह केलं आपण? Any element of x, any element of Q root 2, that is x is equal to A plus B root 2. Okay, arbitrary element घेतला. which is algebraic over Q. Hence, we can say that Q root 2 is an algebraic extension of Q. Okay. Any doubt? लिहून घ्यायचं असेल तर लिहून घ्या पटकन. काही डाऊट्स असतील तर विचारू शकता. काय काही डाऊट्स? रिप्लाय द्या काहीतरी. किती ओके.
No, sir.
Wait a minute. Okay. Now, what is this transcendental extension? The next point is transcendental extension. If there exists A belongs to capital K such that A is not algebraic. Okay, algebraic over the field capital F, then K is called transcendental extension. Of the field F. Okay. For example, the field C over Q is what? Transcendental extension. Why? Because any element, okay, there exists some element belongs to C which is not algebraic over Q. Okay, which one element? Take A is equal to pi. Okay, or take A is equal to E. All these are complex number. Okay, real तर आहे पण complex ही आहेत ते. Okay, because real number is subset of complex number, but which is not algebraic over Q. Okay, similarly, this one is first. The field R over Q is what? Transcendental extension. Okay, let's example. Any doubt up here? Okay. So
No,
we
sir.
move towards next point. Okay. So next theorem is let small a belongs to capital K be algebra over F. Okay, then do that. Any two minimal monic polynomial. Okay, for A, okay, over F are equal ओके, जर हे ए हा कोणताही केचा एक एलिमेंट आहे. ओके, इफ ए इज द एनी एलिमेंट ऑफ के, देन एनी टू मिनिमल मोनिक पॉलिनॉमियल. जर आपल्याला दोन मोनिक पॉलिनॉमियल असतील तर काय म्हणतात, ते दोन्ही पॉलिनॉमियल इक्वल आहे. म्हणजे काय, एखादा एलिमेंट असेल तर मिनिमल मोनिक पॉलिनॉमियल हा कसा असतो, युनिक असतो, हे सांगायचं. ओके, solution. So let us assume that there are two minimal monic polynomial. Okay, assume the contradiction. आपल्याला वन आहे एकच प्रूव्ह करायचं, त्यासाठी काय करायचं, अजून काय केलं आपण, there are two minimal monic polynomial. Two minimal monic polynomials. Okay, satisfies by A over capital F of degree n. Okay, say याला आपण मतलब काहीतरी फायनाइट डिग्री असेल. Okay, let the polynomials are x raised to n plus alpha 1 x raised to n minus 1 plus alpha 2 x raised to n minus 2 plus up to so on alpha n. Okay, x raised to n minus n is 0, so x raised to 0 is 1. And second polynomial, x raised to n plus beta 1 x raised to n minus 1, beta 2 x raised to n minus 2 plus up to so on beta n. Okay, so these are the two polynomials which are satisfied by A. Okay, so then by assumption we have a raised to n plus alpha 1 a raised to n minus 1 plus alpha 2 a raised to n minus 2 plus up to so on alpha n is equal to what? काही लक्ष नाही आहे. 0. Okay, a raised to n plus beta 1 a raised to n minus 1 plus beta 2 a raised to n minus 2 plus up to so on beta n is equal to 0. Okay, why? Because these are the two minimal monic polynomials. ओके, मग जर मिनिमल पॉलिनॉमियल असेल तर काय करणार, तो ए सॅटिस्फाय करणार. सॅटिस्फाय करणार म्हणजे काय, ए इज द रूट ऑफ दॅट पॉलिनॉमियल. दिस मीन्स p of a is equal to 0 here. Okay, now the right hand side of both the equations are 0 now. So equating these two equations we get, so this implies a raised to n plus alpha 1 a raised to n minus 1 plus alpha 2 a raised to n minus 2 plus up to so on alpha n is equal to a raised to n b plus beta 1 a raised to n minus 1 plus beta 2 a raised to n minus 2 plus up to so on beta n. Okay, any doubt up here? Okay, so
No,
by
sir.
the cancellation law, this a raised to n and this a raised to n cancel. Okay, so this implies alpha 1 minus beta 1 a raised to n minus 1 plus alpha 2 minus beta 2 a raised to n minus 2 plus up to so on alpha n minus beta n is equal to 0. Okay, what is the meaning of this sentence? या sentence चालतं काय अल्फा 1 मायनस बीटा 1 ए रेस टू एन मायनस 1. तुम्हाला असा पॉलिनॉमियल एक्झिस्ट झाला आहे ज्याची डिग्री n मायनस 1 आहे आणि तो काय करतोय सॅटिस्फाय बाय a. Okay, but we assumed that the monic minimal polynomial is of degree n. Okay, a ची डिग्री किती अजून केली होती आपण n अजून केली होती. Okay, इथे डिग्री किती येते n minus 1. Okay, so
n
here we
minus
get the polynomial is of degree n minus 1 which is satisfied by a. Okay, so this implies a satisfied a polynomial q of x. Okay, suppose this one is q of x. Alpha 1 minus beta 1 x raised to n minus 1 plus alpha 2 minus beta 2 x raised to n minus 2 plus up to so on. Alpha n minus beta n. Okay, so a satisfies this polynomial q of x is of degree n minus 1. Okay, which is not true. Okay, so this implies q of x must be zero polynomial. Okay, why? Since the degree of at element A is equal to what? N. Okay, here we get the degree of polynomial is n minus 1. So this implies q of x must be zero polynomial. What is the meaning of zero polynomial? All the coefficients of that polynomial, alpha 1 minus alpha beta 1 is equal to 0. प्रत्येक हा coefficient काय असायला हवा तुमचा 0 असायला हवा. म्हणजे तो काय होईल q of x is equal to 0 polynomial. Okay, so here q of x must be 0 polynomial because the minimal polynomial for a, minimal polynomial for a of degree n. Okay, why q of x is of degree less than n. Okay, is it correct? Correct ना? Because the minimal polynomial for a, minimal polynomial काय is of degree n आहे. इथे काय तुमचा q of x काय आलाय डिग्री n minus 1 आलाय. मिनिमल पॉलिनॉमियलचा अर्थच काय तो लोवेस्ट डिग्री असतो. ओके, जो तो पॉलिनॉमियल सॅटिस्फाय करतो. म्हणजे काय असायला पाहिजे तुमचा q of x हा मस्ट बी झिरो पॉलिनॉमियल. Okay, so while q of x is of degree less than n if it is not true if it is not the zero polynomial. जर झिरो पॉलिनॉमियल नसेल तर मग हा स्टेटमेंट करेक्ट आहे. हा स्टेटमेंट करेक्ट आहे म्हटल्यानंतर काय होईल? ओके, हा स्टेटमेंट करेक्ट आहे म्हणजे काय होईल तुमचा डिग्री ऑफ एक काय होईल की हा तुमचा मिनिमल पॉलिनॉमियल येणारच नाही. ओके, बट हियर वी अज्युम दॅट these are the minimal polynomials. मिनिमल पॉलिनॉमियल म्हणजे काय ह्याच्यापेक्षा कमी डिग्री असलेली तुम्हाला कोणतीच पॉलिनॉमियल मिळत नाही जो की हा ए एलिमेंट सॅटिस्फाय करेल. आणि त्या आपल्याला मिळाली. ओके, q of x is equal to alpha 1 minus beta 1 x raised to n minus 1 ह्याची किती येते n minus 1. ओके, एक तर हे ठीक आहे असायला हवा किंवा ते खरा असायला हवा, ट्रू असायला हवा. ओके, मग this implies what? This q of x must be zero polynomial. हा झिरो polynomial असायला हवा. Okay, zero polynomial असायला हवा म्हणजे काय? It implies alpha 1 minus beta 1 is equal to 0. Alpha 2 minus beta 2 is equal to 0. All the coefficients are 0. That implies alpha n minus beta n is equal to 0. Okay, so this implies alpha 1 is equal to beta 1, alpha 2 is equal to beta 2, up to so on, alpha n is equal to beta n. Okay, hence the two polynomials are equal. So x raised to n plus alpha 1 x raised to n minus 1 plus alpha 2 x raised to n minus 2 plus up to so on, alpha n is equal to x raised to n plus beta 1 x raised to n minus 1 plus beta 2 x raised to n minus 2 plus up to so on, beta n. These two polynomials are equal. Okay, thus we prove that the two minimal monic polynomial, two minimal monic polynomial for a over f are equal. Okay, any doubt? काय
No,
केलं
sir.
आपण आधी दोन पॉलिनॉमियल घेतले जे डिफरंट आहेत आपण असं केलं. पण जर डिफरंट आहे असं आपण असं केलं तर काय येईल? कॉन्ट्रडिक्शन येईल. काय कॉन्ट्रडिक्शन येईल? आपल्याला क्यू ऑफ एक्स असा एक पॉलिनॉमियल मिळेल ज्याची डिग्री n मायनस 1. ओके, आणि तो काय करतोय? एला सॅटिस्फाय करतो. म्हणजे काय? आपला कोणतं स्टेटमेंट रॉंग होईल? हा स्टेटमेंट रॉंग होईल. लेट अस assume that there is two polynomial monic minimal polynomial by a over f is of degree n. ओके, जर मिनिमल पॉलिनॉमियलची डिग्री n असेल तर n पेक्षा लहान असलेली डिग्री जो अशी पॉलिनॉमियल तुम्हाला मिळणारच नाही. ओके, मग हे कशामुळे होत आहे? ते आपण डिफरंट assume केलं. ओके, हे झिरो पॉलिनॉमियल असायला हवं. ओके, आधी दोन वेगळे आहेत म्हणून सांगितले, कुठेतरी कॉन्ट्रॅक्शन दाखवून ते दोन्ही एकच आहे आपण प्रूव्ह केलं. ओके, एनी डाऊट? Okay.
No, sir.
Can we move towards the next point? The next term is let the A belongs to K, capital K, is algebraic over F. Okay, and the P of X is be a minimal polynomial. Minimal polynomial for A. Okay, over F. Then prove that. Prove that P of X is reducible over capital F. Okay, what is the statement? Is theorem that A belongs to A with any algebraic over F. म्हणजे हा algebraic element आहे over F, and P of X is the minimal polynomial. That means the lowest degree polynomial is satisfied by A. That is P of X is equal to 0. Then prove that P of X हा irreducible पाहिजे over F. Okay, P of X irreducible आहे म्हणजे काय याचा अर्थ? तो रिड्यूस होत नाही. We cannot write P of X is equal to Q of X into G of X, काहीतरी असेल. such that the degree of q of x and g of x is less than p of x, and these are the two polynomials are belongs to capital F of x. Okay, this is the definition of irreducible. Cannot write म्हणतोय मी असं. ओके, असं लिहू शकत नाही. ओके, irreducible polynomial शिकलाय आपण मागच्या सेमेस्टरला. ओके, proof. Suppose p of x is minimal polynomial in f of x. Okay, p of x हा काय minimal polynomial, that is what p of a is equal to 0. Okay, is it correct? Reply द्या काहीतरी. Suppose we have to do that p of x is irreducible over f. Suppose here the p of x is not irreducible. Okay, suppose the contradiction p of x is not irreducible over q. What is the meaning of not irreducible? Not irreducible म्हणजे काय? Reducible. Okay, हा not आणि हा is गेल्यानंतर काय राहील? Reducible. हा p of x is काय? Reducible over q. Okay, not irreducible. The meaning of this sentence is irreducible. काही डाउट आहे का? P of x is not
No, sir.
irreducible over
No, sir.
q, then it implies then P of x reducible असेल तर काय होईल? P of x can be written as product of two polynomials. Okay, P of x is equal to f of x into g of x. Okay, where f of x and g of x are polynomial of positive degree. Okay, this is the definition of what? Irreducible polynomial. Okay, in capital F of x, that's the ring of polynomial, so that each of them is of degree. Okay, प्रत्येकाची डिग्री कशी असायला हवी? Less than that of p of x.
P of
Okay.
x.
Now put x is equal to a. So what we get? P of a is equal to f of a into g of a. Okay, but a is what? P of x is a minimal polynomial. The minimal polynomial implies what? P of a is equal to a हा minimal polynomial आहे. कोणाचा? P of x चा a चा minimal polynomial. तर P of a काय येईल? So f of a
0
into g of a. Okay, but we know that if f is the field, if we know that if capital F is field, then f of x काय असतो तुमचा? Field असतो काय? Integral
domain.
Okay, here the product of two elements, okay, is equal to 0. But f of x and g of x belongs to capital F of x, and f of x आहे integral domain आहे. तर दोघांचा product 0 येत असेल. So this implies either f of a is equal to 0 or g of a is equal to 0. ओके, हे तरी झिरो पाहिजे किंवा हा तरी झिरो पाहिजे. But degree of f of x or degree of g of x is less than what? Degree of p of x. So here we get the polynomial f or g. Okay, such that the degree of f of x and g of x is less than what? F of x, p of x. Okay, म्हणजे काय होईल हा? हा, therefore a satisfies either f of x or g of x. Okay, so this implies degree याची कशी आहे ह्याच्यापेक्षा लेस आहे कोणापेक्षा f of p of x पेक्षा has the one. Okay, so this implies p of x is not minimal polynomial over f, which is contradiction. Why? Because we assume that p of x is assuming. Okay, look at here. P of x is minimal polynomial. Okay, why we get this contradiction? Because we have assumed the wrong. What is assumed? P of x is not irreducible. काय assume केलं होतं कशामुळे contradiction? पण ते आपण असा assume केलं. Okay, so here which is contradiction. So this implies P of x is reducible. The statement is wrong. Okay, so this implies P of x is an irreducible polynomial in capital F of x. Okay, any doubt? Okay, समजते काही फास्ट होते अजून स्लो घेऊ. Okay, wait a minute. नवीन गोष्टी शिकायचं तुम्हाला शांत आहे फर्स्ट सेमिस्टरला नव्हता शांत.